Welcome to an extraordinary journey to the deepest parts of our oceans, where darkness prevails and life thrives against all odds. Today, we will explore the unique ecosystems around hydrothermal vents, revealing the incredible extremophile organisms that call these extreme environments home, and the astonishing adaptations that allow them to survive and flourish. Imagine descending thousands of meters below the ocean's surface, into the abyssal depths where sunlight never penetrates. Here, in the pitch-black waters, hydrothermal vents provide a surprising source of life. These vents are like underwater geysers, spewing superheated mineral-rich water from beneath the Earth's crust. The discovery of hydrothermal vents in the late 1970s revolutionized our understanding of life on Earth, revealing ecosystems that defy conventional biology. Hydrothermal vents are formed when seawater seeps into the Earth's crust, becomes heated by underlying magma, and then rises back to the seafloor, carrying dissolved minerals and chemicals. The vent fluids can reach temperatures of over 400 degrees Celsius, 750 degrees Fahrenheit. But the immense pressure at these depths prevents the water from boiling. When this superheated water meets the cold deep-sea water, it creates striking chimney-like structures, often called black smokers, due to the dark plumes of mineral particles they emit. Life around hydrothermal vents is centered on chemosynthesis, a process in which microorganisms convert chemicals from the vent fluids into energy, rather than relying on sunlight as in photosynthesis. These chemosynthetic bacteria and archaea form the base of a unique and complex food web, supporting an array of extremophile organisms specially adapted to thrive in these harsh conditions. Let's start with one of the most iconic inhabitants of hydrothermal vents, the giant tube worm, Riftia pachyptila. These remarkable creatures can grow up to 2.4 meters or 8 feet long and have no mouth or digestive system. Instead, they rely on a symbiotic relationship with chemosynthetic bacteria housed within a specialized organ called a trophosome. The bacteria convert hydrogen sulfide, a toxic chemical abundant in vent fluids, into organic molecules that provide nourishment for the tube worms. In return, the tube worms supply the bacteria with a steady stream of hydrogen sulfide and carbon dioxide, creating a mutually beneficial relationship that allows both organisms to thrive. Another fascinating resident of hydrothermal vents is the Yeti crab, named for its hairy, white appearance. These crabs have bristle-like structures on their pincers that harbor chemosynthetic bacteria. By waving their pincers in the mineral-rich vent fluids, Yeti crabs cultivate and harvest the bacteria, which serve as their primary food source. This unique adaptation allows them to make the most of the limited resources available in their extreme habitat. The Pompeii worm, Alvinella pompeiana, is another marvel of hydrothermal vent ecosystems. These worms live in tubes attached to the sides of black smokers, where temperatures can vary drastically from near freezing to over 80 degrees Celsius, or 176 degrees Fahrenheit. To survive these extremes, Pompeii worms secrete a thick layer of mucus that harbors heat-tolerant bacteria. This symbiotic relationship provides the worms with thermal insulation and protection from harmful chemicals, while the bacteria benefit from a stable environment and a steady supply of nutrients. Hydrothermal vent ecosystems also host an array of unique mollusks, such as the Scaly-foot Gastropod, or armored snail. This snail has a distinctive shell covered in iron sulfide scales, providing protection from predators and the harsh vent environment. Inside its body, the Scaly-foot Gastropod also harbors chemosynthetic bacteria in a specialized gland, allowing it to thrive in nutrient-poor conditions. Larger predators, such as the hydrothermal vent octopus, also call these depths home. These octopuses have evolved to withstand the high pressures and low temperatures of the deep sea, preying on smaller vent inhabitants like crabs and shrimp. Their presence at hydrothermal vents adds another layer of complexity to these unique ecosystems. The discovery of hydrothermal vents and their inhabitants has profound implications for our understanding of life on Earth and the potential for life beyond our planet. The ability of extremophiles to thrive in such inhospitable conditions suggests that life could exist in similar environments elsewhere in our solar system, such as the icy moons of Jupiter and Saturn, where subsurface oceans may harbor hydrothermal activity. Hydrothermal vent ecosystems are also of great interest to scientists studying the origins of life. The conditions at these vents, with their rich chemical environment and abundance of energy sources, resemble those of early Earth, where life is thought to have originated. By studying hydrothermal vent communities, researchers hope to gain insights into the processes that led to the emergence of life and the potential for life to arise in other parts of the universe. Despite their remoteness, hydrothermal vent ecosystems are not immune to human impacts. Deep-sea mining, aimed at extracting valuable minerals from the seafloor, poses a significant threat to these fragile environments. The disruption of vent habitats could have devastating consequences for the unique species that depend on them. Conservation efforts are essential to protect hydrothermal vent ecosystems and ensure the preservation of their remarkable biodiversity. The study of hydrothermal vents also offers potential benefits for biotechnology and medicine. The unique enzymes and compounds produced by extremophiles in these environments have applications in industrial processes, pharmaceuticals, and even the development of new materials. By exploring the deep sea, we may unlock solutions to some of the most pressing challenges facing humanity. In conclusion, hydrothermal vents are a testament to the resilience and adaptability of life. The extremophile organisms that thrive in these harsh environments have evolved remarkable adaptations, providing valuable insights into the limits of life on Earth and the potential for life beyond. As we continue to explore the deep sea, we uncover new wonders and deepen our understanding of the extraordinary diversity of life on our planet. Thank you for joining us on this journey into the depths of the ocean and the unique ecosystems around hydrothermal vents. Stay tuned for more in-depth explorations of the wonders of nature and the extraordinary adaptations of wildlife around the world.